Okay, let's look at this question here. A bag contains 3 red balls and 3 green balls. Balls are drawn without replacement, 1 by 1 and without replacement. Okay, show that the probability that the first 3 balls drawn are red is 120. I think it's not an issue, although they are identical. Because without replacement and this probability, we can just choose them. First 3 are red, will just means that we take 3, choose 3. Then after which it's just 1. That's the total number of ways of choose 6 balls. The total number of ways of 6 choose 3. Okay, or we could see it as 3 over 6 times 2 over 5 times 1 over 4. Either way, we'll get 1 over 20. Okay, so that's that. 1 over 20. Great. Then let's look at the next one. So for part B, find the probability that the first 3 balls drawn consist of 2 red and 1 green in any order. Hence or otherwise show that the probability that the third red appear on 4th draw is 3 over 20. I think this is pretty okay. So B, we find the probability the first 3 balls drawn consist of 2 red and 1 green. Okay, similarly, you could just basically out of the 3 red choose 2 times out of the 3 green choose 1 over 6 choose 3. Or if you want to use the classical, like the method, I call it the classical method you learn in secondary school, that would be actually 3 over 6 multiplied by 2 over 5 multiplied by green, which is 3 over 4. Remember to multiply by 3 factorial, 2 factorial, because this is the number of ways which you could arrange RRG. The answer is 9 over 20. I think this is pretty okay. 9 over 20. Great. Then after which we are we say that the hence or otherwise show that the probability that the third red appear on the 4th draw is 3 over 20. I think this is pretty okay. So so the required probability would we use the first part where the first 3 consists of 2 red, 1 green. Then the subsequent one has to be red, right? So I'm just going to use the probability that we found just now, 9 over 20. Multiplied by the 4th is red would be then you're left with 1, right? Because you have 3 red, you pick 2 already, you have 1 over 3. Okay, the 4th is red is 1 over 3 because subsequent 3 quarter here, so the 4th draw you only left with 3 balls, so that's that. So this case here we'll get 3 over 20. Okay, so the part C, find probably the third red appears on the 5th draw. Okay, great. C. So basically this means that the first four draws has got 2 red, right? In order for the 5th draw to be the third red, this is a third red. So meaning the first 4 you have 2 red and 2 green. Okay, so that's about it. So this case here I could just use basically 3 red over 6 multiplied by 2 red, then multiplied by 3 green over 4, 2 over 3. Remember to multiply 4 factorial, 2 factorial, 2 factorial. Okay, because there's a number of ways you can arrange 2R and 2 green. Then the subsequently we have the subsequent which is red, which is half. So this will be 310. Okay, so let's look at D. Okay, D is the random variable X, which is the number of draws required up to and including the one on which the third red ball appears. Great. Tabulate the probability that the X. Okay, basically what it means is how many times you need to draw to get the third red ball. Number of draws. Okay, I don't minimally you need 3 draws, right? Because the first part is minimally you need 3 because that would be like red. The number of draws requires 3 draws. So this is, I think this is pretty okay. This will be the probability here will be, which is actually the probability of the part A. Okay, so this is 1 over 20. Then after which, of course, you can have 4, meaning to say the first 4 draws, meaning the first 3 draws, this is red. Then this guy here would have 2 red and 1 green. Okay, that would actually be the answer in part B, right? Because the 4th draw is red, the third rate appear on the fourth draw will be 3/20. So of course, then after which you have the fifth one. It'll be 1, 2, 3, 4, 5, 5 draws. Then this will be rate, the third rate. The third rate, right? So meaning there are 2 red here and 2 green, which is the answer we found just now. Third rate on fifth draw, which is 3/10. Okay, I think this is the last one because this is the you exhaust the sixth draw. Will mean you exhaust everything. You have 6 draw here. 1, 2, 3, 4, 5, 6. Then this would be the third rate, right? So meaning here you have 2 red, 1, 2, 3, 4, 5, and 3 green, which is 3 green. You have 3 green balls. Yeah. So essentially you could calculate it, or I think it's good to calculate it so that you at least know whether it checks out, because you can take 1 minus entire thing, right? Then you calculate and see whether it checks out the probability there. So this guy will be 3 choose 2 times 3 choose 3 over 6 choose 3. Sorry, 6 choose 5. Okay, multiplied by the 1. This is definitely red. 1 choose 1 over 1 choose 1 if you want to, which I get half, which tell you this guy here. Okay, so this is my probability distribution table of X. Okay, then what we want is EX, the expected weighted average. Just multiply them, should be quite okay. So the answer is 5 1/4. Okay, so that's how you do this question here.